Okay, so let's say we had an equation that looked like this: y equals 2x cubed, right? And here we see that exponent with the x, but there's nothing, I'm not sure why that's there, with y. That would be a function too. Here, x equals y minus 1. I'd like to actually just solve the equation for y. So in other words, I'd like to add 1 to both sides. All right, that cancels out. Here I get y is equal to x plus 1. Is that a function? Absolutely, as well. So there's our first page. Let's take a look here at what else we have. Okay, Aubrey needs to remove 1 point from the graph so it represents a function. So in other words, it's telling me right now this graph is not a function. And so if we do our vertical line test, we would see right here is what is causing this to not be a function, right? I could draw a line through all of the other points on here and it would just go through one of them, right? This is what's causing this not to be a function. So she needs to remove one of the points from the graph. So we could either remove, let's see, we can remove this point here, or, right, we can get rid of that point right there. So either one of those. It looks like they've given us some ordered pairs, and then it says choose all that apply. So it doesn't matter which one of these I get rid of. I just need to get rid of either of them. The top point, this one up here, this is located at -1, 3. So that would be letter B. The second point, right, this one down here is -1, 1. So I think if we get rid of either of those points, we will have ourselves a function. All right, write a number from the box to complete the table of values so that it represents a function. So here is all of my inputs: 1, -2, 0, and 3. Remember, if you want to be a function, your inputs cannot repeat. So in other words, I really can't use 1 or a -2 or a 0 or a 3. All right, I can only use these 3 numbers here. I can use them in any order I want, because remember, it doesn't really matter if you know, 1 input or 2 inputs give me the same output. I just can't have any of my inputs repeat. So I'm going to put -3 right here. I'm going to go 2 right here and -1 right here. But again, we can put any of those 3 numbers we had in either of these boxes here. Look, we can't use the other numbers: -2, 0, 1, 3 cubed, right? And here we see that exponent equation with the y equals, but there's nothing represent a function y with y. That would be a function too. Here, x equals y minus 1.
Yes.
I'd like to actually just solve the equation for y.
It is a function.
So in other words, I'd like to add 1 to both sides.
I would say 2 things. One,
all right, that cancels out. Here I get y is equal to
the
x
equation is
plus
solved
1.
for y.
Is that a function? Absolutely.
All right.
As well.
And secondly,
so there's our first page. Let's take a look here at what else
y
we have.
has no.
Okay. Aubrey needs to remove 1 point from the graph so it represents
I'm okay
a function.
if
So in
the
other words,
x
it's telling me right
variable
now this graph
has an
is not
exponent.
a
I'm
function.
not okay.
And
if
so if we do
y
a vertical
variable
line test, has one. If we were to see this on a graph, it would actually look something right
just
here.
Like
Is
okay,
what
so
is
number
causing
4, yes,
this to not be
we
a
have
function. Right? I could draw a line through all of the other points on here, and it would just go through one of them. Right? This is what's causing this not to be a function. So she needs to remove one of the points from the graph. So we could either
the graph represents
remove
Sophia's distance from home.
let's see,
So we really need
this
to
point
understand
here,
what's going on here.
right?
So
we can get rid of
time increasing,
that point
right?
So
there.
so either one of those.
Right?
It looks like they've given us some ordered
so this
pairs,
is
and then it
time
says
0
choose all
and
that
distance
apply.
0.
So it doesn't
and
matter
all
which
the way
one
down
of these
here
I
at
get
the
rid
end.
of.
This is
I just
some
need to get
time.
rid
Again,
of,
I don't have
either
an
of
idea.
them.
This could be 2 minutes or 3
the
minutes
top
or
point,
an hour later, but
this
at some
one
point
up here,
in
this is
time,
located at
it's increasing all
-1,
the way down here.
3.
So
that would be
distance
letter
from
B.
home again.
The second point,
we start at
right,
0
this
and
one
work
down
our way
here
up.
is -1,
Again,
1.
this
So I think if
this
we get rid
number
of either of
that's
those points,
up here, this
we
could
will have
be
ourselves
5
a
miles
function.
or 10 miles. or 100
All right,
yards,
write a number
or
from the box
1,000
to
feet,
complete
or who knows
the table of values.
what it
so
is,
that
but it is some
represents a
arbitrary
function.
distance
So
that's further away from
here
home.
is
So
all
here,
of my inputs: 1, negative
if
2,
I look at this, it looks
0,
like
and
she
3.
starts out.
Remember, if you
know,
want
right about
to be a
here,
function, your
and
inputs
she's moving
cannot
at a
repeat.
constant
So,
rate, getting
in other
closer
words,
to
I
home.
really can't
and then at some point in
use
time, something
1
happens, and
or a
she's
negative
going
2
back, and she's getting
or
further
0
away.
or 3.
Then her distance isn't
Right,
changing
I can
for a while.
only
Time is
use
changing, right?
these
But there
3
is
numbers
no
here.
distance
I can
change
use them
for
in
some
any
amount
order
of
I
time.
want, because
And
remember,
then we see
it
a
doesn't.
constant
There
all
doesn't
right,
really matter if
return
if,
and
you know,
finally,
one
you know,
input
at
or
some
2 inputs
time
give
in
me
the
the same
future,
output.
we've gotten
I just can't
back,
have any of my
and
inputs
we are at
repeat.
home.
So,
So
I'm going to put
at
negative
this point right here,
3 right here. I'm going to
we
go
are
2
home,
right here
right,
and
at
negative
that
1 right
point
here. But again, we can
right
put
there.
any of those 3 numbers.
So let's go
in
through these
either
options here, see
of
which one
these
matches
boxes
up.
here. But we can't use the
Sophia
other
starts
numbers:
driving
negative
home,
2, 0, 1.
stops on her way to pick up a friend, then continues
Does the
driving
equation
home.
y equals x
Right?
represent
Well,
a
if
function
she's stopping
y,
on her way to pick up the
or why
friend,
not?
she didn't get further away from home. So I don't
yes.
think that one.
Right? It is a function. Really works.
B, on the way
I would
home
say
from
2
work,
things.
Sophia
One,
makes 2 stops at different stores, staying in
the
each store for a
equation
few
is
minutes
solved
and then
for
driving
y.
home.
All right.
Okay,
And
again, it doesn't make any
secondly,
mention if the stores are getting closer to home or the stores are getting away, but there's 2 of them.
Y
So we would see, you know, 2
has
bricks. If we were
no
thinking about this on a graph, like maybe she would go here while she's at one store.
Again,
then
I'm
she gets
okay
closer,
if the
you know,
x
she's at another
variable
store, and then
has an
finally she's home.
exponent.
So our
I'm
graph
not
would look
okay,
something like that.
if the
But ours
y
doesn't.
variable
So I don't think it can be
has one. If
If we were
B.
to see this on a graph, it would actually look.
Let's look
something
at letter
just
D
like
real
that.
quick. Sophia walks
Okay,
to the
so
bus
number
stop.
4, yes, we have
waits
a
for the
function,
bus.
then takes the bus
There.
home. So
right,
again, if we were
moving
thinking about that on a
on.
graph, so maybe here she is. She walks to the bus stop.
One of my favorite stuff here.
and
So
she
we've got
waits
graphing
for
stories.
some period of time, and
here.
then she goes home. Looks close, but it
graph
doesn't
represents
have
Sophia's
it doesn't
distance
have
from
that.
home.
Hey, getting further away.
All right, so we
Point.
really
None
need
of
to
those do.
understand.
C is the one that we're looking for here. She starts
going
to drive
on
home,
here. So
forgets her phone at work.
time,
Oops.
right?
Increasing.
That's
This
right.
point
So
right here, where she
think
says,
about,
"You know what? I
right,
forgot my
everything
phone."
here is
Then
0.
she goes
So this is
back to
time
work.
0 and distance 0.
Again, getting
right?
further
And
away from
all
home.
the way down here at
Obviously,
the end.
she
This
goes
is
and gets
some
her phone at
time.
work.
Again,
That's
I
why
don't
we
I don't
see
have an
that-
idea. This
that
could be
line
2 minutes or 3
right
minutes
here.
or an
And then
hour
finally she
later.
makes
But
her
at
way
some
back into
point
the car
in time,
and is
that's
happy 'cause
increasing
she's
all the way
finally
down
home.
here.
Okay, here we've got a sketch of graph.
Distance from home again.
About battery life.
We
So
start
it
at
says the
0
battery
and
life
work
for
our way
Jacob's
up.
laptop
Again,
decreases
this,
as he uses
this
it
number
while it's
that's
unplugged.
up here. This
So
could
it
be
finally
5
dies.
miles or 10
it takes
miles.
Jacob a while
or
to
100
find
yards or
a
1,000
place
feet.
to charge
or
the battery.
Who knows
When he
what
finally plugs it in,
what
the
it
battery
is, but
charges
it is
and
some
gains more
arbitrary
battery life.
distance that's
Sketch
further
and
away
graph.
from home.
So
So
again,
think
here,
about here's
if
time
I look
0.
at this,
It looks like she starts
Here
out.
is, I don't know, let's just
right
say,
about here.
you know,
And
60
she's moving at a
minutes
constant
from
rate,
now.
getting closer.
Our battery
to
life
home.
here,
and then at
you
some
know,
point
again,
in time,
down
something
here is
happens,
0,
and
and
she's going back, and she's getting further away.
100% all the way up here. So
Then
our battery
her
life
distance
doesn't
isn't
start at
changing for a
0,
while.
it starts
Time
at
is
100.
changing,
So I know
right?
I'm going to
But
have to
there
start
is
my graph
no,
up here.
Distance change for
And
some
we're
amount of
draining
time.
the entire,
And
right?
then we
'Cause it
see
says in
a
the first one,
constant,
his laptop
right,
decreases while he
return
uses it
and
until
finally,
it dies. So
you
that
know, at
means
some
time
he's
in the future,
using it,
we've gotten
right?
back,
And now, boom,
and we are at home.
So
all the
at
battery
this
life's
point
out
right
of it.
here,
It takes him a while.
we are
to
home,
find a place
right?
to charge
at
the
that
battery.
point.
So
right
in other
there.
words, it's not like it.
So let's
charges
go through these
immediately,
options here and see
right?
which one matches
He's
up.
wasting time.
Sophia starts
figuring
driving
out,
home,
stops on her way to pick up a
plug,
friend,
or, you know,
then
maybe he
continues
lost his charger, didn't
driving
remember where
home.
to put it. Some amount of time goes by
Right?
before
Well,
he
if she's stopping on her
finally
way to pick up the
plugs it in,
friend, she didn't get
right,
further away
and begins to charge
from
the
home.
battery.
So I don't think that one
until it gains more
more
life.
life. So your graph should look something like that. Again, you
Really
might
works.
have steeper lines, or maybe
B,
not
on
as
the way
steep
home
as
from work,
mine.
Sophia makes
but it
2
should have that
stops
general
at different
shape. There's
stores,
3 parts
staying in
to
each
it.
stores for a few minutes, and then driving home.
Okay. And last page. Here
Okay,
we
again,
go.
it doesn't make any mention if the stores are getting closer to home or the stores are getting away, but there's
All right,
2
Micah
of them.
takes a train
So
to
we would
visit a
see,
friend.
2 bricks. If we were
The
thinking about
graph.
this
Let me
on
see
a
over
graph,
here.
like maybe she would go here
Shows the
while
trip
she's at one
from
store,
his
then
home
she gets
in New
closer
Jersey to his
she's
friend's
at another
house in
store,
Maine.
and then finally she's home. So our graph would look
That's
something
all
like
we know.
that.
He starts at his house in
But
New
ours
Jersey, goes to
so I don't
son's house,
think
and
it can
which
be,
part of the graph shows
B.
Micah's weight at the train station?
let's look
in
at letter
New
D real
Jersey?
quick.
Sophia walks to the bus stop,
Okay.
waits for the bus,
Um,
then takes the bus home.
I think
So,
it might be beneficial
again,
to
if we were
us
thinking
if we
about
figure
that
out
on
what
a graph,
each
so
one
maybe
of
he, she is,
these
she walks to the bus stop.
and she
points
waits
represent.
for
So in
some
other words,
period
with
of
each
time,
part
and
of
then
these,
she goes
of these
home.
lines
Looks close, but it
means,
doesn't
so,
have
like,
what is
that
section
getting
1
further
and
away
what is section
point.
2.
None of those do.
And then
C is the one that we're
3
looking
and
for
4
here.
and
She
5.
starts
I think
to
if
drive
we can
home,
write out what those
forgets
are,
her phone at work.
I
Oops.
think we'll be able to
Right?
answer
That's
the
this
question
point
we
right
see
here,
right here,
which
which
is
says,
which
you know
part
what,
of
I
the graph
forgot my
shows
phone.
Micah's
Then
weight
she goes
at
back
the
to
train
work
station in New Jersey.
All
Again,
I know
getting
is
further
this.
away from home.
Right here, Micah
Obviously,
takes
she
a
goes
train
and
to
gets her phone
visit a
at work.
friend. That's why we see that
That line.
his trip starts
right
from
here.
his home in New
And then
Jersey,
finally she makes her way back
goes
into
to
the
his
car
friend's house
and
in
is happy
Maine.
because she's finally home.
Okay.
Okay, here we've got a sketch
So
graph
he must start
about battery life.
So it says the
at
battery
his
life for
house
Jacob's
right
laptop
here at the
decreases
origin
as he
so he's
uses
got to
it
start at his
while
house
it's unplugged
and go to the train
until it
station.
finally
So I
dies.
think that's section
It
1.
takes
I think
Jacob
this
a
is,
while to find a place
would
to charge
say
the battery.
travel
When he finally plugs it in, the battery charges and gains more battery
from
life. Sketch a graph. So again, think about here's time 0. Here is
the train
I don't know,
station.
let's just say
Right, and this is
going to be
60
where he lives,
minutes
which
from
is
now.
in our battery life
New
here.
Jersey.
Again, down here
Right,
is
then
0,
section 2,
and
we don't see
this would be 100
any distance from
all the way
home.
up here. So our
increasing.
battery
So
life
this
doesn't
must
start at
be,
0; it starts at 100. So I
weight,
know I'm going to have to start my graph up here at the
and
train
we're
station.
draining the entire, right? Because it
And
says in
this
the
one
first
is
one
in
he
New Jersey.
his laptop decreases while he uses it until it
section
dies. So that
3.
means
This is our distance
he's
from home is
using it,
increasing here. This
right?
must
And
be
now,
when we're on the
boom.
train. So this is
all the battery life's out of
the
it.
train ride. It takes him a while to find a place to charge the battery. So in other words, it's not like it
And-
charges immediately, right?
Oh,
He's
sorry.
wasting
Let's-
time figuring
I
out.
just wrote that in. This should be
A
3.
plug, or maybe he
Sorry,
lost
this
his
is
charger, didn't remember where to put
3.
it. Some amount of time goes by
4.
before he
let's
finally
write 4
plugs it
over
in.
here.
Section
Right?
4. This
And
is where
begins
he's
to charge the battery
until it
at
gains
the
more life. So
station.
your graph should look something like that. Again, you might have
In Maine.
steeper lines, or maybe not as steep as
handwriting's
mine.
really bad right now.
But it should have that general shape. There's
and then
3
section
parts to it.
5
Is where he's going to travel. And last page. Here we go. All right, from his friend's house. Or, I'm sorry, from the station. All right, Micah takes a
From
train to visit a
station
friend. The
to
graph that we see over here
friend's
shows the trip
house.
from his home in New Jersey to his friend's
All right,
house.
so which
in
part of the graph
Maine?
shows
Micah's weight at the train station?
That's all we know. He
in
starts at
New
his house
Jersey.
in New Jersey.
Goes to his friend's
There
house.
you go.
in Maine.
Letter
Which
B.
part of the graph?
Again,
shows
I think if
Micah's
we
weight,
understand each of those parts before we
at
try
the
to
train
answer the
station
question,
in New Jersey, it makes it
it
better. It looks like Shakira
Okay.
chose C. How did she get that answer?
I think it might be beneficial to us if
C
we figure out what
was
each
4,
one of these
right? So
points
points
represent.
represent.
So in other words,
up
what each
here.
part of these lines
4 was the weight
means.
So
like the station.
what
Maine.
is
So she
section
just picked
1
the wrong
and what is
station.
section 2?
That's how she got that answer.
And then 3 and 4
Apparently
and
she's
5.
better
I think
at
if we can
singing
write out
than
what
she is
those
at
are,
answering,
I
this
think we'll
math
be able
question.
to answer the question we see right
And
here, which is which
last
part of the
question of
graph
the day.
shows
Graph
Micah's
shows the
weight
temperature for
at
a
the
day
train
in a
station
city.
in New Jersey.
Tell whether
All
each
I know
statement
is
is true or
this.
false.
So we've got
Right here, Micah takes a train to
looks like
visit a
4
friend.
parts to our graph here.
Right?
Again, let's understand
his
the
trip
graph
starts
before
from
we,
his home in New
try
Jersey.
to answer any questions.
Goes to his friend's house.
So
in
here is at
Maine.
time and temperature 0.
Okay.
And then as our time
So
increases,
he must start
again, I'm assuming this is for a whole day.
at
so
his
this is
house
24
right
hours.
here at the origin.
So he's got to start at his house
Right,
and
so
go
we'll
to
say
the train
24
station. So I
hours.
think that's sometimes
Section
it might help
one, I
us to
think
put
this
numbers
is,
on here.
the temperature.
I would say
again, travel.
we know it starts at 0, maybe all the way up here is,
from
I don't know, 100
house
degrees or something.
to
And so, maybe now it's a
the
little bit
train
easier to
station.
see, hey, temperatures
Right,
are
and this is
increasing
gonna
or
be
steady
where he
or-
lives,
or
which is
decreasing.
in
But let's
New
take a
Jersey.
look at each section. So here we go.
Right,
Section
then
1, the
section
temperature
2,
is
we don't
the
see,
temperature increases for
any
a few
distance
hours.
from home
Is that true or is
increasing.
that
So
false?
this
Well, here's
must
our temperature.
be
It starts here.
weight
And yeah, it goes up
at the train
over
station.
a period of time, and it steadily goes up. So I
And
would
this
say
one is
this
in
one,
New Jersey.
Section 2, temperature decreases.
Section 3, this
for a
is our
few
distance
hours,
from
right?
home is
Do we see that
increasing
right
here.
here?
This must be when we're on the
No,
train.
we see
So
the
this
temperature
is,
staying the same, right? It's not going
the
up
train
or down.
ride.
So I think that's false. Section 3, temperature stays the same for a few hours.
And
Section 3 is
I'm
not
sorry.
staying. Section 3
Let's-
actually increases
I
very
just
rapidly.
wrote that in. This should
So
be
that's
3.
false. Section
Sorry,
4, the
this is
temperature decreases
3.
from the high for the day
4
until the
let's
end of
write
the day.
4
Yeah, this
over
is
here.
the
This
section
is the
4.
highest
This is
point,
where
right, that we
he's
see all the way up here.
and
At
then
the
it
station.
goes down the rest
in
of the day. So
Maine.
yeah, I'd say that is very much true.
Handwriting is really bad right now.
So there you go, guys.
And
Hopefully you
then
did
section
well on that.
5 is where he's
again, if
going
you have
to
questions over one of them or you didn't understand it,
travel,
you can always watch the video or come grab
from
your
his friend's
favorite math
house.
teacher.
I'm sorry,
all
from the
as well.
station.
Have a great day.
From station to friend's house.
All right. So which part of the graph shows Micah's weight at the train station in New Jersey? There you go, letter B. Again, I think if we understand each of those parts before we try to answer the question, it makes it better. It looks like Shakira chose C. How did she get that answer? C was 4, right? So, our part of the graph up here. 4 was the weight in the station in Maine, so she just picked the wrong station. That's how she got that answer. Apparently she's better at singing than she is at answering this math question. And last question of the day. Graph shows the temperature for a day in a city. Tell whether each statement is true or false. So we've got, looks like 4 parts to our graph here. Again, let's understand the graph before we try to answer any questions. So here is at time and temperature 0. And then as our time increases, again, I'm assuming this is for a whole day, so this is 24 hours. Right, so we'll say 24 hours. Sometimes it might help us to put numbers on here. The temperature, again, we know it starts at 0. Maybe all the way up here is, I don't know, 100 degrees or something. And so, maybe now it's a little bit easier to see, hey, temperatures are increasing or steady or decreasing. But let's take a look at each section. So here we go. Section 1, the temperature increases for a few hours. Is that true or is that false? Well, here's our temperature. It starts here, and yeah, it goes up over a period of time, and it steadily goes up. So I would say this one, true. Section 2, temperature decreases for a few hours, right? Do we see that right here? No, we see the temperature staying the same, right? It's not going up or down. So I think that's false. Section 3, temperature stays the same for a few hours. Section 3 is not staying. Section 3 actually increases very rapidly. So that's false. Section 4, the temperature decreases from the high for the day until the end of the day. Yeah, this is the highest point, right, that we see all the way up here. And then it goes down the rest of the day. So yeah, I'd say that is very much true. So there you go, guys. Hopefully you did well on that. Again, if you have questions over one of them or you didn't understand it, you can always watch the video or come grab your favorite math teacher, and all is well. Have a great day.